Have you ever wondered why something we've never evolved to do is healthy for us? Going to the gym, playing tennis, riding bicycles? I couldn't think of anyone more qualified to answer that question than paleoanthropologist Daniel Lieberman. He couldn't be at our TEDx longevity conference because he was overseas, so he let us film his talk in his office in the spectacular Peabody Museum.
Hello, my name is Dan Lieberman. I'm a professor at Harvard University, and I study the evolution of physical activity and how it's relevant to health and disease. Now, before we get started, let's get a few definitions under our belt. The first thing I want to discuss is the difference between physical activity and exercise. So physical activity is just any bodily movement produced by skeletal muscles, but exercise is voluntary, discretional physical activity for the sake of health and fitness. And health span is the number of years we live without serious chronic disease, but lifespan is just how long we live. Now, wouldn't it be great if we had a magic bullet, if exercise was one of them, to live a long and healthy life, right? That'd be fantastic, right? And this idea actually originates from a long time ago, from the Middle Ages. There's an old German folktale called Die Freischütz, which is about a marksman who makes a deal with the devil, and the devil gives him 7 magic bullets. They're silver, and 6 of those bullets that will hit whatever target the marksman wants to hit. But the trade-off is that the 7th bullet, the magic bullet, will hit whatever the devil wants to hit. And that's a trade-off that we should keep in mind. Because the first person to think about magic bullets in medicine was Dr. Paul Ehrlich. And he came up with this idea around the turn of the century that medicine would come up with drugs, magic bullets, that would cure disease with absolutely no side effects. And the first magic bullet he thought he discovered was something called salvarsan, which was a kind of arsenic that was used to treat syphilis. And the good news was that it did treat syphilis pretty well, but the bad news was that people given salvarsan often had diarrhea, they had nausea, and sometimes they died. Remember that 7th magic bullet. And now, of course, nobody uses it anymore. Now we use penicillin, which was invented in 1928, which has turned out to be a better medicine for syphilis and many other diseases. So since then, people have proposed many medicines and various other lifestyle treatments that are supposed to help us live to be 100. These are often touted as magic bullets, right? You've probably heard of caloric restriction, the intermittent fasting, taking ice baths, and there are all kinds of pharmaceuticals like rapamycin and metformin and NADH, and some of these do have benefits, but the sad fact of the matter is that unless you're a mouse or a fruit fly, there's really no compelling evidence that any of them have any substantial effect on human, or even for that matter, primate longevity. And the reason for that has to do with evolution. Remember, nothing in biology makes sense except in the light of evolution. And we evolved to grow old and die. Sorry, that's just the truth, right? So natural selection cares about one thing and one thing only: how many offspring we have who survive and reproduce. So natural selection wants us to live and stay healthy as long as we're reproducing, but once we stop reproducing, we enter what's called the selective shadow. Now, humans have managed to extend that selective shadow for a while, right? Because grandparents help their children and their grandchildren survive, and so they have some selective benefit. But eventually that dwindles, and natural selection doesn't seem to care about us. And it seems that humans evolved to live about 7 or 8 decades, and after that, well, it's because of good luck. Now, what about exercise? And it is true that exercise really is very good for us, but it's also true that exercise is not a magic bullet. And the argument I'm going to make today is that physical activity improves health span by slowing aging and decreasing our vulnerability to disease. And before medicine, think about it, health span equaled lifespan, because there was no doctor to keep you alive after you got sick. Now, the reason for this, the explanation, the why behind this, is what we call the active grandparent hypothesis. And so my colleagues and I, Aaron Bagish, Aimin Lee, and others, have argued that there's been selection in human evolution for moderate levels of lifelong physical activity that extend our health span and hence our lifespans. And it's for that reason that physical activity, exercise, is good for us. So the active grandparent hypothesis makes 2 kind of predictions. There are 2 parts to the hypothesis. And the first is that humans evolved to be moderately physically active and to stay active as we age, including after we stop reproducing. And the second is that there was selection for physical activity to slow aging and decrease vulnerability to disease, thereby extending health spans, which, as we've already discussed, extends lifespans. So let's talk about the first part, that humans evolved for lifelong physical activity, including as grandparents. And it's true, humans did evolve to be grandparents. Take our closest relatives, chimpanzees. The average chimpanzee in the wild lives to be 33 years old. Some of them live to be about 50, maybe. That's very rare, but it can happen. But for the most part, very few animals, chimpanzees included, ever survive after they stop reproducing. But humans in all kinds of populations all around the world live to be post-reproductive. Typical hunter-gatherers live to be about 20 years or so after they stop reproducing. Their modal age of death is about 68 to 78 if they survive childhood. And importantly, those years are not spent just inactive, they're spent to be active, right? Humans evolved to be much more physically active than our ape ancestors. Typical chimpanzee walks maybe 2 to 3 kilometers a day, and they take maybe, 4,000 steps a day. A typical hunter-gatherer takes about 15 to 20,000 steps a day. Per kilo, hunter-gatherers spend about twice as much energy per kilo on being physically active per day than our ape cousins. And importantly, that physical activity occurs as we age, right? So Americans are pretty inactive, as we all know. A typical American in their 20s might be, spend 30, 40 minutes a day being physically active. And by the time most Americans hit the age of 70, they may be doing 10 to 20 minutes a day of moderate to vigorous physical activity. Hunter-gatherers in Tanzania are way more active. In their 20s and 30s, they're doing 3-4 hours a day of physical activity. And although that declines by the time they're 70 or 80, they're still doing 2 to 3 hours of physical activity a day. That's well more than 10 times more physical activity per day than a typical American. So we evolved to stay active as we age, and the reason for that is that activity is to do stuff. It's not like we don't retire, we don't go to the beach, we don't go to Florida. Hunter-gatherers continue to gather, they continue to hunt, they continue to take care of children, and they produce an energetic surplus which they supply to their children and their grandchildren. And that surplus can amount to somewhere between 250 to a whopping 3,000 calories per day. That's substantial. So yes, human beings were selected to be moderately physically active and to stay active as we age, including after we stop reproducing. Now, the second part of the active grandparent hypothesis is that there was selection for moderate physical activity to slow aging and decrease vulnerability to disease, thereby extending health spans, and then, as we talked about before, also lifespans. And if you want proof of this, one of the best studies ever done was the Harvard Alumni study done right here in my university, Harvard University, by Ralph Paffenbarger. And Paffenbarger studied over 20,000 Harvard alumni, and he looked at them from all ages. And by the way, when you do that, you're basically correcting for socioeconomic status. And what he showed was that alumni below the age of 50, who were getting about 2,000 calories a week of exercise, had 21% lower death rates than alumni who were inactive. And that's after correcting for smoking and various other sorts of things like that. By the time they got to their 50s, the more physically active alumni had 36% lower death rates. And in their 70s and their 80s, those exercising alumni had 50% lower death rates than sedentary alumni of the same age. That's an amazingly large effect, right? And what he's showing here is that as we get older, exercise not only helps you stay healthy, it becomes more important as we get older. The reason for that is because exercise causes stress, and that stress turns on a whole raft of beneficial effects. And there are really two kinds of this stress. Now, the first kind is energetic stress. Like I went for a run this morning. I spent probably about 500 calories running, and I can only do so many things with the calories my body has. And if I spend 500 extra calories exercising, that means I'm not going to spend 500 calories on other activities that my body might engage in. And one of them is fat storage. Everybody knows, I hope they know, that physical activity is one of the best ways, maybe the best way, to prevent weight gain. So a lack of physical activity is one of the ways that encourages weight gain. And in a famous experiment, for example, Bente Petersen in Copenhagen took a whole bunch of young, healthy Danes, right, who were normally very active, and made them sit on a couch for 2 weeks and eat the same amount of food. And she scanned them before and after those 2 weeks. And just in 2 weeks, they gained 7% more body fat, including 7% more in their bellies. And that's concerning because belly fat, or visceral fat, is highly inflammatory. Now, another study also looked at another kind of energetic stress, which is how you allocate energy towards reproduction. Remember, I can only do so many things with my calories. So if I'm spending more energy in physical activity, I'm not going to spend as much energy on reproduction. And in a famous study done here at Harvard, my colleague Peter Ellison looked at women who are running 20 kilometers a week, right? That's not a huge amount. So that's about 180 calories a day, and compared it to sedentary women. And the sedentary women were taking that extra energy and they're plowing it into reproduction by increasing their levels of estrogen and progesterone. 50% higher levels in the second half of the menstrual cycle. And higher levels of progesterone and estrogen increase rates of cancer. So the energetic stress from physical activity decreases inflammation, which is involved in everything from metabolic syndrome to cancer to heart disease, and it also decreases reproductive hormones, which decrease cancer rates. Now, the other kind of stress that physical activity causes structural stress. Now, when I was running this morning, for example, my mitochondria were generating all kinds of ATP to fuel my body, but my mitochondria were also spewing out all kinds of reactive oxygen species, which cause widespread damage throughout my body. I was getting mutations in my DNA. That damage is causing my telomeres at the end of my chromosomes to shorten. It's damaging cells. It's causing tears in my muscles, causing cracks in my bone. And of course, if all that damage were, we did nothing about it, right? We'd die soon after exercising. But instead, exercise turns on a wide range of repair and maintenance mechanisms that repair all that damage, and in fact increase capacity. So the next time I do a 5-mile run, I might actually be able to do it with more ease, right? And there are a lot of these, right? So one of them is, when I produce all those reactive oxygen species, my cells also produce a ton of antioxidants that mop up all that damage. When I stress my mitochondria, my cells are also being induced by exercise to repair and produce more mitochondria that keep my cells healthy. I'm getting DNA damage from all those reactive oxygen species, but I'm turning on all kinds of enzymes that repair DNA. I also turn on factors that repair my brain and actually cause growth of new brain cells. One of them is called brain-derived neurotropic growth factor that's turned on by exercise. My muscles, when I'm exercising, are producing molecules that actually suppress inflammation, keeping my inflammation levels low, and my immune system is getting turned on. I produce more natural killer cells and cytotoxic T cells and antibodies, all of which are going to protect me from infectious diseases. So the bottom line is that when you exercise, you slow rates of aging, you slow the rate at which you lose muscle, you decrease your risk of dementia, you decrease inflammation, you decrease your risk of infectious disease, including, by the way, COVID, and many, many more kinds of functions like that improve our health. So the bad news is that exercise really isn't medicine. It's not like a pill that you take, like Salvarsan or penicillin that gets rid of a disease. Instead, it's really the better way to think about it is that we never evolved not to be physically active. And the result of that is that when we're sedentary, habitually sedentary, that leads to a lack of repair and maintenance. So that's the bad news. But the good news is that just a little bit of physical activity, you don't need to do very much, stimulates a wide range of repair and maintenance mechanisms that overshoot any of the damage that the physical activity causes, right? So I like to think about it as like, imagine spilling coffee on the floor, right? And then you clean up the floor is going to be cleaner after you spilled the coffee than before, because we overshoot the repair and maintenance. So just 150 minutes of physical activity a week, that's 21 minutes a day, right? That's not very much, just like walking, right? Can lower an average person's risk of heart disease by 20%. That's a lot. It lowers the average woman's risk of breast cancer by 30 to 50%, and it lowers the average person's lifetime risk of Alzheimer's disease by a whopping 45%. And if you look at the overall effect on mortality, and I'm showing a graph here of minutes per week of moderate to vigorous physical activity on the x-axis against the relative risk of all-cause mortality, just 150 minutes a week of exercise, again, 21 minutes a day, leads to a 30% lifetime reduction or yearly reduction in all-cause mortality. And getting up to the levels of hunter-gatherers results in a 40% reduction. That's a massive effects. And it's hard to turn those health span estimates to longevity estimates, but the best guesses are that adds at least a half a year to as many as 7 years to your life. So in short, we never evolved not to engage in moderate levels of lifelong physical activity, and therefore lack of physical activity, or its modern manifestation exercise, fails to slow aging and increases our vulnerability to many diseases. So in the final analysis, exercise is not a magic bullet, but it sure is a great way to add life to your years, and it can also maybe add a few years to your life. Thank you.